All right, hi students. I'm going to move myself over here. This is Miss Woods, and today we are going to talk about homeworks number 3 and 4, which covers the topic of angles. So these are our objectives today, which is name and classify angles and measure and construct angles and angle bisectors. And this is all the vocabulary we are going to be covering. So here is an angle. So what we need to know about an angle is it is formed by two rays or sides with a common endpoint called the vertex. So you can see here, this is the vertex of my angle. It's the point at the very tip. And an angle is actually made by two rays. I can see one ray over here and one ray over here. These rays have this common endpoint, which is the vertex, and that forms an angle. So the set of all points between the sides of the angle is the interior of an angle. So all of the points here are the interior or the inside of the angle, and any point outside of an angle is called the exterior. When you name an angle, if I want to name this angle, I will always put the angle side in front of it. That means I'm talking about an angle. So I can call this angle SRT, as written over there. I can also call this angle TRS, and I can call this angle by a point in the interior. So in this situation, it would be called angle 1. Now, what I want you to understand is the vertex of the angle will always be in the middle when naming an angle. So in this case, the vertex is R, which is why R is in the middle of naming the angles. Either one of these names you can use to name this angle. It does not matter which one. Okay, here's an example. I'm going to move myself over here. So let's look at this description. I want to name this angle, but the thing is, with this angle, there's not one angle, there's 3 different angles. Okay, so the first angle I can see is angle BAC. BAC. This is just one angle. I can also see the angle CAD, which is right here, CAD. So now I see 2 angles. I see BAC and I see angle CAD. I also have angle BAD, BAD. So that is 3 angles in this picture right here. I could also call BAC actually CAB. It does not matter the order as long as the vertex, in this case, which is A, is always in the middle. So remember, don't let this fool you. There are actually 3 angles in this picture. All right, let's name all of the angles in this diagram. Okay, just by looking at this diagram, I can see 3 different angles again. I can see angle QTR, which is this angle. I can see angle RTS, which is this angle, and I can also see angle QTS, which is this whole angle. Now, when I want to name it, I could name this. Here are possible ways to name it. RTQ, which is the same angle as QTR. I can also name this angle STR, which is also the same as angle RTS. Or I can name it by a point of its interior. So in this case, it could be angle 1 or angle 2. Now remember, the vertex of the angle is always in the middle when naming the angle. Okay, here's an angle measure that I drew out. Let me move myself here. So I drew this angle here. Okay, there are multiple different angles within this angle. Now D in this angle is our vertex. So when naming angles, D will always be in the middle. Now, I want to know the measure of the angle. What is the degree of the angle? When I'm asking you what the measure of the angle is, I always write M. So I'm asking you, what is the measure, M, of the angle ADB? Let's look at angle ADB. ADB. I can see that this angle right here is 30 degrees. So I'm going to write equals 30 degrees. I also may ask you, what is the measure right there of angle BDC? So if I'm looking at angle BDC, I could say that is a 40-degree angle right there. Now I'm also could ask you, what is the measure of angle ADC, which is right here, ADC. That consists of both this angle right here, ADB, and angle BDC. So I'm going to add these two angles together to give me this one big angle. So measure of angle ADC is 70 degrees, which is angle 30 plus 40 added together. All right, so we're going to talk about measuring angles. And to measure an angle, you use a protractor. And a protractor is actually measured in degrees of a circle. So there are 360 degrees of a circle, so the protractor is actually a big circle. And each degree you can see within the circle. So I'll show you a picture. So right here, let's first look at this one right here. This is a protractor, okay? It's a circle, and it is a circle with 360 degrees. Okay, you can see here it starts at 0 and it keeps going, and goes to 360 degrees. Now if I give you this angle here, right there, I'm going to place the vertex in the middle of the protractor, and I'm going to measure this angle so I can see that here is one ray, here is the other ray. I can see that it starts at the 80 degree and goes to 105 degrees. Okay, but I want to know what the measure of the angle here. So what I'm going to do is I can know that I'm going to do 105 minus 80, which will give me 25 degrees. So I know that this here is a 25 degree angle. I can also count the amount inside. I know 80 to 90 is 10 degrees, and then 90 to 100 is 20 degrees, and then I'm going to add that extra 5, which is 25 degrees. Now if I look at this picture, I'm only using half of that protractor. This makes it much easier to use half the protractor because I can just start at 0, and I can see that this angle keeps going up to 60 degrees. So I can see that this angle here is 60 degrees. Most people find it easier to use just half of a protractor because this can kind of get messy when you use the whole one. All right, these are different types of angles that we're going to work with. So we're going to work with acute angles, right angles, obtuse angles, and straight angles. Now, I kind of want to start here at the right angle because a right angle is always 90 degrees, always. Now, sometimes an angle is less than 90 degrees. And by the way, you know an angle is a right angle just by this box. It is telling you it is a 90-degree angle, that box. Now, let's just say that angle is smaller than 90 degrees. You call that an acute angle. It's very cute. That's how you can kind of remember. It's less than 90 degrees. It's smaller. Another type of angle is an obtuse angle over here, which is larger than 90 degrees. So you can see here, here's your right angle, which is 90 degrees. When the angle is smaller, right there, you can see it's less than 90, which is an acute. And if it's larger than 90, you can see it's an obtuse. Right here, a straight angle. This is always the easiest because it looks like a straight line, but this actually forms a 180-degree measure, okay, which is half of a circle. So this angle obtuse will always be in between 90 and 180 degrees, and an acute angle will always be between 0 and 90 degrees, and a straight angle, which is a line, will always be 180 degrees. So by looking at this angle here, I want to know, is it an acute angle, which is less than 90 degrees? Is it a right angle, which is 90 degrees? Is it an obtuse angle, which is more than 90 degrees? Or is it a straight angle, which basically makes a line and it is 180 degrees? Now by looking at this, I can see that there's no box, so I immediately know that it is not a right angle. I can see that it's a little smaller than a right angle, so in that case, this would be considered an acute angle. It is not an obtuse angle because it is not larger than 90 degrees, and it is not a straight angle because it does not form a straight line. All right, let's look at this. So in this question, it wants us to find the measure of each angle, then classify each angle as acute, right, or obtuse. So when looking at this angle, I first want to look at angle WXV. WXV. I want to look at the measure of that angle. I can see here that it starts at 150 and goes to 180. So I want to do 180 minus 150 to give me a 30-degree angle. Okay, so I know that this angle here is 30 degrees. It is not 150 degrees. It is not 180. We want to know the measure in between that. Okay, because that angle is less than 30 degrees, we know it has to be an acute angle because acute angles are less than 90 degrees. Now, when looking at angle ZXV, I want to look at what that measure is. So I can see here that it starts at 50 and goes all the way to 180. So I want to find out what that angle is. So I'm going to do 180 minus 150, which will give me 110. Okay, so if I know that this is 110 degrees, I know it is more than 90 degrees. So I know it's going to be an obtuse angle. As you can see, angle ZXV is larger than 90 degrees, which is why it's an obtuse. All right, let's look at angle BOA. Angle BOA. You can see here that angle or ray OB is at 140 degrees and angle or ray 0A is at 180 degrees. So I want to know what 180 minus 140 is, which is just 40 degrees. I know 40 degrees is less than 90 degrees, which is why that makes that an acute angle. Now our last one, let's look at angle EOC. EOC. Okay, I can see it starts right here at 0 and it goes all the way to about 105 degrees, it looks like. 105 degrees is more than 90 degrees. So in that case, it would be an obtuse angle.